Welcome to qnawire.
You are lowering two boxes, one on top of the other, down a ramp by pulling a rope parallel to the surface of the ramp. Both boxes move together at a constant speed of 15 centimeters per second. The coefficient of kinetic friction between the ramp and the lower box is, so we've mu k is 0.444, and the coefficient of static friction is 0.800. What force do you need to exert to accomplish this? Okay, so let's start with a free body diagram. So here's our ramp. This is 90 degrees. This is theta. And our boxes are sitting on top of each other. We have a normal force that comes out perpendicular to the surface. This is static friction, while the bottom one is kinetic friction. The bottom one is moving and the top box is kind of staying in place. So static versus kinetic. And then dealing with the weights, you're going to have, let's call positive y, positive x. So you're going to have a weight that pulls down at m1 plus m2 g, and then by geometry cosine of theta. This is m2g sine of theta, and this is m1g sine of theta. Okay, so for part A, and then part B asks us the magnitude and direction of the friction force on the upper box. So we can actually start with looking at the angle. So the angle is equal to the inverse tangent of y over x. So from the figure, 2.5 meters over 4.75 meters. So it gives us an angle of 27.8 degrees. So looking at the horizontal direction, we have Newton's second law. So Fs plus Fk is equal to m1g sine of theta plus m2g sine of theta. So plugging in values, and we get that this is 365 newtons. So since we know this, we can find the normal force. The normal force is m1 plus m2g cosine of theta, since it's opposite. So it's not moving in the y direction, so the acceleration is equal to 0. So the normal force is equal to 694 newtons. So we also know that Fk is mu kn. So plugging in mu k, plugging in n, we get 308 newtons. So watch out for normal force versus newtons. So plugging this into this equation, and we get a force due to static friction of 57 newtons. So the question asked us, what force do you need to exert to accomplish this? We need to overcome static friction, so 57 newtons. Part B, we need the magnitude and the direction of the frictional force. So the total force due to friction is equal to m2g sine of theta, since that is what we are overcoming, looking back at our figure. Which is equal to 146 newtons. And it needs to be going upwards.